All right, here we are in part 2. So let's begin. It says here we have circle T shows another simple manhole cover design. And it says that the measure of the arc KM measures 80 degrees and measure of the arc LN measures 30 degrees. They want us to consider the line segments KL and MN. They want us to use a straight edge to draw a secants that coincide with each line segment. And where do the secants intersect is a question. Then they want us to label that point as point P on the figure. So go ahead and take a screenshot with me. And we're going to go to our pictures, locate it, and click Edit and Markup. All right, so let's go ahead and draw these line segments, these secants. Okay, remember a secant goes, think of it as like a cupid arrow going into the heart and out the other end. And so here we have one secant. Maybe I should extend it further. Make them quite long because they've got to intersect. There we go. And make sure we add arrows in the ends because secants are lines, not line segments. And remember, secants, like I said, it goes into the circle and out the other end, and they intersect here at this point right there, and they want us to call that point P. Okay? Where do they intersect? They intersect at point P. So we're going to click done, and go ahead and upload that picture. Moving on to question 2 here, if it allows me. Okay. Now they want us to draw a chord. They want us to draw a chord KN. So we're going to go back to our picture, and we're going to draw, click Edit, Edit, chord KN. So I'm going to use a different color here. And now they want us to draw a chord. Remember, a chord, unlike the secant, a chord just stays inside the circle and it's a line segment. So it ends, it does not have arrows. All right, now you would upload that picture. All right, number 3, it says, can you determine the measure of angle KPM with the information you have so far? If so, how? Explain your reasoning. So let's go look for angle KPM. Oh, I want to just highlight it for you here. KPM, KPM. That yellow angle, can we find the measure of that angle? Well, we know that the arc KM is 80 degrees. If this was an inscribed angle, that means the vertex would have to be on the circle. I would have been able to find the angle, but since they intersect outside the circle, we have no way at this point of knowing how to find that measure, the angle the measure of that angle. So take a quick pause and type in, we do not have enough information. So let's see if we can figure out a different way of finding the measure of that angle. Number 4 says, use information given in the figure to name the measures of any angles that we can find, and explain how we determine those answers. So can we find, is there another angle in this picture where we would be able to figure out its measure? Well, I just mentioned inscribed angle. Remember, an inscribed angle is an angle whose vertex is on the circle or at the edge. And so that one right there that I just highlighted is an inscribed angle. And we know that this angle right here measures 80 degrees. And we know that this arc, I said angle, I meant arc. So that arc right there measures, let's just do an arrow, 30 degrees. That's what was given, right? Because angle KNM, the highlighted in yellow angle, is an inscribed angle, and we learned, I think that was last class or last lesson in Unit 1, that inscribed angles are half of the measure of its intercepted arc. And so therefore, the measure of this yellow angle, inscribed angle, has to be half of the measure of that blue arc. So what's half of 80? So we have to take 80, and we're going to divide it by 2. That would give us 40. So the measure of this angle right there would be 40. How did we find it? Because it's an inscribed angle. So you're going to go and make sure you type that in. Moving on to question 5. How does KPN relate to triangle KPN? So let's go back to our picture and let me erase some of this stuff. Triangle KPN. Okay, so we are going to erase this information here. And I erased a very important line, which was my secant line. And let's go ahead and draw that again. Looks like I might not be as beautiful as it was before, but if it was beautiful. All right, so they say, oh, I also erased my line segment KN, which is this blue line. So let's go ahead and draw that again. And that's going to create that triangle KPN that they're talking about. So this is the triangle that is talking about. So how does angle KPN relate to the triangle KPN? So let me just highlight the angle here. This angle KPN, how does it relate to this triangle? Well, the only thing I can think of is that it's inside the triangle. It's one of the interior angles inside that triangle. So you can go ahead and type that in. All right. So let's continue here with number 6. Write a statement showing the relationship between the measures of angle KPN, the measure of angle NKP, and the measure of angle KNM. So where are these angles? Well, the angles that it's being talked about here is the ones highlighted in yellow. So this angle, that angle, and this angle right here. So those 3 angles are all angles inside of the triangle. And what we can say is that they all equal 180, right? Remember, all of the angles inside of a triangle equal 180. So to write a statement, we can, you can be typing angle KPN and add it to angle NKP and add it to angle KNM. Oopsie. It's supposed to be an M, as in man, equals 180 degrees. Okay? You can tuck that in. They all add up to 180. Moving on to number 7. What is the measure of angle KPN? What is the measure of angle KPN? So let's use information that we have just found to get our answer here. So let's see. We know, let me erase some of this green, and let's redraw that blue line. Okay, so we know that the measure of this angle, let me write it in green, this inscribed angle is 40 degrees, right? That looks like 46. So this is 40 degrees. If that's 40 degrees, then we have here what kind of angles do those form? Those angles are supplementary. Remember that from last semester? And they add up to 180. So therefore, this angle I keep erasing the picture. Let's redraw that line. Okay, so if they have to add up to 180, then this angle right here would have to be 140, because 140 plus 40 is 180. And let's see here. Okay, now remember we didn't talk about this angle right here, this one right here, LKN, but we can find the measure of that angle, right? Because let me erase this arrow that's confusing you probably about this talking about this angle right here is 140. There we go. So this yellow angle I have highlighted is also an inscribed angle. And remember we talked about how this arc right there is 30 degrees. So remember, how do we find the measure of the inscribed angle if we know the measure of the arc? That's correct. We have to divide by 2, right? So we can say that the measure of this angle over here is 15. 15 is half of 30. Okay? All right, so far we know that one angle is 15. And down here we actually wrote it down. So which angle is that? KPN is the one we're looking for. We know angle NKP we just found is 15. And we know the measure of angle KNM is 40, which helped us find the measure of angle KNP, which is 140. And all of that has to equal 180, right? But we don't know this one. So what we're going to do is we're going to solve for x, if you will, right? So let me write this up here so you can kind of see where we have. I'm going to say it's an x because we're looking for this x right here. Okay? So x plus 15 plus 140 equals 180. Okay, because it's a triangle. We are going to add 140 plus 15. So what's 140 plus 15? If you said it was 155, that's correct. And that's going to give me what? So from here we have to subtract both sides by 155. Let me subtract 155 from both sides here. And so our answer is going to be what? So what's 180 minus 155? Should give you 25. So the measure of this angle right here is 25 degrees. All right, so remember, just to recap, what we did here is we figured out using inscribed angles and supplementary angles to find the measures of this angle, of exterior angle, okay? And we also used the knowledge that all those angles inside of a triangle add up to 180. Okay. Number 8, describe, so number 7 would be 25 degrees. Number 8 says, describe the measure of angle KPM in terms of the measures of both arcs intercepted by KPM. Describe the measures of KPM in terms of the measures of both arcs intercepted by KPM. So is there a rule? Basically, they're saying, can you kind of come up with a rule that we don't have to go through all of these steps to find that measure of that exterior angle? Is there something that we can come up with that will be easier to work with? And this is where it's okay, there's no right, I mean, there is a right answer, but it's your time to just kind of see if you can figure out a rule that will help us here. So I'm going to go ahead and erase all of this. And as I'm doing that, you should be kind of analyzing and saying, hey, I wonder if there is a shortcut to all of this madness that we just have to do. Okay? So let's see what we can observe here. So once again, we still want to find that yellow highlighted angle. This arc, remember this arc was 80 degrees and this arc was 30 degrees. Let me just highlight those arcs so you know what I'm talking about. So this arc and this arc, one was 80, the other one was 30. The final answer, we said that the angle here was 25. So do you see a relationship between 80, 30, and 25? What do you think? Pause this video and see if you can figure it out. All right, hopefully you're back, and I hope you were able to figure out that the measure of the angle is equal to 1/2 the difference of the arcs. The difference, I'm going to put DIFF of the arcs. Okay? So you can type this however way you want. I would say maybe the exterior angle is equal to 1/2 of the difference of the arcs. The difference means we're subtracting. So if you take 80 and you subtract the smaller one, so the big one minus the smaller one, so 80 minus 30, you get 50. Then you take 50, you divide it by 2, and you get to 25. I told you there was a shortcut. Okay? Let's go on to number 9. So number 9 tells us it appears that the measure of the exterior angle of a circle is equal to 1/2 of the difference of the arc measures that are intercepted by the angle. Okay, this observation that we just came up with is a theorem, so it has been proven. A mathematician decided to prove this, and this is the rule that they came up with. All right, so an angle with a vertex located in the exterior of a circle can be formed by a secant and a tangent. Remember what a secant is? It's a line that goes into the circle and out the other end, and then a tangent just kind of touches the surface and keeps on going. So we're going to go ahead. It says to use this circle O to draw and label an exterior angle formed by a secant and a tangent. So I'm going to take a screenshot, and we are going to hit cancel, and we're going to move on to this picture. And they want us to draw a secant. So I'm going to go ahead and draw a secant. And remember, a secant is a line that goes into the circle and out the other end. And it's a line, so that means it's got arrows. And then I'm going to draw a tangent. Remember, a tangent has to intersect it. And it touches the circle at just one point. So I'm just going to go ahead and draw it like this. Okay, and this is the tangent line. Okay, and the tangent line, let me erase that arrow. It looks a little funky. And they basically intersect right there. Now, I just want to extend this blue line so you understand that this is a line. That's the tangent line. Okay, and the tangent line, let's say, it's not a perfect picture, but the tangent line is only touching the circle at one point. And there we have it, and the angle is this angle right here. This is the exterior angle that's being formed. So go ahead and upload that picture. All right, number 10, if we can get there. Okay, case 2, we have another situation where we can have an exterior angle of a circle, and it can be shown when you have two secants. So this time we're going to take a screenshot and we're going to draw an exterior angle where we have, instead of this one where we have a tangent, which is the blue one, and a secant, we're going to draw two secants. And we just worked with this one, so this should be easy. We worked on a problem that was dealing with this situation. So here we have two secants, and remember, secants have that situation where we have two arrows on both ends, and the angle here, exterior, is that one right there. You're going to go ahead and upload that picture. We're going to move on to question 11. Here's our next case. It says we can draw and label an exterior angle formed by two tangents now. So we can have two tangents instead of two secants. So let's take a screenshot. And we're going to draw the two tangents. And remember, two tangents, tangent lines are lines that touch the circle at just one point. So I'm just going to do the best that I can here to illustrate that. So those are two tangents. As you can tell, it does not go inside the circle. It just kind of brushes the circle at one point each. Okay, it's not a perfect picture, but I don't expect you to be an artist. So there we go. Those are two tangents, and they form an exterior angle. All right, moving on to question 12. You have some fill in the blank question here. This is the rule that we just have talked about, the theorem that a mathematician had to sit and prove. And basically this theorem states that if an angle is formed by two intersecting chords or secants, and we also know that we can have two tangents in a circle, such that the vertex of the angle is in the exterior of the circle, an angle in the exterior or outside of the circle, then the measures of the angle is half of the difference of the measures of the arcs intercepted by the angle. So the formula, remember, is big arc minus small arc divided by 2, and you get the measure of the exterior angle, okay? Last but not least, to show the exterior angles of a circle theorem previously stated, we will find, and here I would just have you take a picture of, or upload the same picture that we uploaded earlier, okay? So let's see if we have it. If not, I'll take a screenshot just in case. So they just want us to illustrate what we just already talked about. Let me just go ahead and do that really quickly. To apply this theorem, once again, to just reiterate what we talked about, we're going to go ahead and draw two secants in this case. It doesn't have to be. We're going to draw two secants. We're going to illustrate this rule that we just talked about. So these are two secants. And so the measure of, I'm going to highlight the angle that we're looking for. I'm going to go ahead and say it's x. Like we said before, is, and somewhere on this picture you can say x is equal to 1/2. And we're going to subtract, okay, the big arc minus the small arc. And I'm just going to highlight the small one is 30, and the big one is 80, okay? And so that would be 80 minus 30, and that's the rule. So what is 80 minus 30? That's 50. And which gives me 25. So the angle, the exterior angle here is 25, okay? So go ahead and upload a picture that looks like this into your Canvas. And I hope that was helpful, and I'll see you in the next video.